Hello, today I'm going to give a presentation about the reputation systems and the delegated proof of stake and the use cases within blockchain. So what can blockchain provide for these reputation systems to make it more transparent, decentralized, and yeah, innovative? The reputation system in its current state. It's important to note what the current state is to see how we can improve this. Um, there are examples of reputation systems like Google, Amazon, IMDb, and Rotten Tomato. They have very centralized reputation systems, meaning that the data that they collect is for them, and they can do whatever they want to do with it. Um, it is partly decentralized in a way that you can vote yourself, so you can put a stake on something and say, well, this is something that I really like. This is something that I didn't like. That's decentralized, but the data ultimately is centralized. So decentralized is the way that people can actually vote. The problem is with decentralized reputation systems is that they use the data for their own advantage. An example can be given with Facebook. Facebook, they collect likes, they collect what kind of posts you tend to click on, what kind of news you like to see, and from there they create a personalized experience to create some kind of what you would call a bubble, where the people or the user tend to stay in, which is not a good thing because you stay really one-sided and one line without any other insights or interpretations. Another important part is the sharing economy. The sharing economy has to do with the human factor inside the reputation system. The sharing it means that a human is more complex than just the economy implies it to be. So a trust protocol requires way more research because it needs to be compliant to the sharing values that a user has. That comes down. Then I come down to the human psychology. That's related to the sharing economy. The human psychology is of course very complex. I'm not going to go all too deep into that, but it is important to note that introvertly, so inside ourselves, we tend to give our own voting, reputation, and scaling, which means that we have our own opinion about something, whether it can be trustworthy or whether it can be risky. For example, if you want to jump off a ledge, is it high? Is it not high enough? That's all kind of choices that you make. Related back to the reputation systems and the blockchain, I would give some. I did some research about how it can be implemented and what the possibilities in technology are. So important thing about if you have a reputation system on a blockchain is that the reputation is portable, which means that if another blockchain has a certain reputation, and that blockchain can be, for example, a marketplace, that marketplace can send the information to a different blockchain about the reputation of a buyer or a seller and verify that it is an actual valid seller with good reputation. So that's another way to use it. Off-chain registration by using the oracles. Shortly saying, well, I explain it a lot more in my assignments. Oracles are essentially sensors that can track real life data from the outside world and translate it back into data to a server, or in this case a blockchain. It has to be usually it has to be online, but it also can be offline. So related to scalability, an offline oracle can be more useful because it can collect a lot of data and then send it all the data from that off chain to the online blockchain, the public blockchain. Another thing is the reputation schemes or flow-based models. I found an interesting research about the Markov model. The Markov model implies that if you have a certain amount of values, for example, you have value A, value B, and value C, the Markov model will, you will put those three values inside the model, and then the Markov model will determine how many times um, a different value has been chosen. So it can be either A 2 times, or B 2 times, 4 times, or C 6 times, and then it keeps on repeating. With a Markov model, the probability to choose the same value again um, related to the last value uh, is higher. So that means that if he chose value A, the chances that he choose value A again will be higher than he would then go to the value B. That's shortly saying a Markov model. It goes more extensively than that, but this is in short how it works. In this case, you can this results in more trust transivity, which means that you can see which choices are going to be made in the future, which makes it more transparent, trustworthy. Another thing is the scalability related to the up and down voting. It can be a downside because the more users on a voting system or reputation system, the higher the scalability becomes, because you have more users, of course. The delays and the latency will increase, and it will also determine on how many up and down votes on a certain time period will be given. So you have like higher traffic and lower traffics. The latencies can be variable in that case. So that's not really a good foresight for it, but it could be solved by different protocols. For example, delegated proof of stake, but I will come to that later. Centralized versus decentralized reputation systems. Well, coming back to the first slide, a lot of reputation systems right now are centralized, and they have your data, and they do what they want with it to improve their systems. Sometimes it can be an advantage for you, but sometimes also a disadvantage. This means that the importance of a decentralized reputation system is that it's more transparent, it's more trustworthy, and people have they have the feeling that they can participate inside the system in order to choose for a delegate, which can be a third party or a trustworthy person. In this case, or in the situation of a marketplace, it could be a seller. So you could get better reputation with a decentralized system because it's more open, and people tend to it can be more cross related with the reputation portability. So the reputation can be like I said, can be linked to a different blockchain, which makes it more decentralized and open. Centralized has, of course, its advantages that it has a fixed amount of scalability, which means that the scalability is related to the power of the centralized server. The latencies are not that high, and companies tend to have more advantage in this because they have more saying in this. So it can go both ways. The important part is that the users can have advantages with the decentralized, and the centralized are more for the companies, like mentioned. Voting and democracy. I really found out in my research that like a delegated proof of stake would be a nice protocol, a possible solution to a reputation system, because a proof of stake usually is related to the highest bidder or the highest stake, and that has the highest amount of authority. With a delegated proof of stake, the amount of stakes that you can give is related to all the transactions that has been done in the past. So there's an average out of it, which means that usually everybody can put a stake inside a vote or a reputation. So I would prefer using the delegated proof of stake in order to make it more equal, to create more social equality. Another thing is important thing is to mimic the real world. I think that it is important, and what I found out in research was that a lot of voting is based on democracy, because a lot of Western countries are based on the democracy society. This means that the applications of a blockchain reputation system also needs to be partly related and identical to the democracy voting system. This makes it easier for the users to understand it, and also makes it more related to the human values and the society values that we have here in these Western countries. So, for example, the Dutch general election days, they have like a voting system where you can choose for a party and then for a specific person, and from there the most votes, that party gets the lead or can choose a delegation of different parties to cooperate with to fill the cabinet. This means that if you use this voting system inside a blockchain, you can get people to vote with a delegate proof of stake with a certain fee, for example, and then they can choose the overarching third party. So this is the same way as a Dutch general election. The stakeholders, like I said, like with a centralized reputation system, they tend to have different goals than the users. So it is important to note that if you want to develop a decentralized reputation system on a blockchain, that a fully decentralized would not be ideal, because you need to take in account that the companies also want to do something with that data. A different kind of use cases. I'm gonna finish my presentation with some interesting finds about the implementations at this point of reputation systems and blockchain. Important thing, like I mentioned, is the marketplaces. They can communicate between each other to validate the reputation of someone, of a seller or a buyer. An example can be given is Augur. It's an application that makes sure that every user has its different needs, and that it can make like future predictions based on what people think is viable at this point, is important at this point, and then they can put stakes in that to vote for it. Users can put stakes in that to vote for it. So there are also voting applications. There are like multiple voting applications for the blockchain as well. For example, Polis, they want to create a decentralized application where you can create a poll or like a vote, and other people can vote for this, can up or down vote this in order to make a project go on or be funded in the case of an ICO or a project, or not in this case. Important thing with ICOs and crowdfunding is also that related to reputation systems, is that ICOs can tend to be fake, or let's say like they have a high goal and they tend to be like idealistic and not realistic. So they tend to not to be like really accurate. So it's important with those reputation systems, people can vote for ICO, and then related to the votes, they can see if it's a good project and a solid project, and then after that they can start investing in it by means of investing cryptocurrency or real fiat fiat money. Or in a case of some applications, they use tokens, of course, related, backed up by a cryptocurrency. So I think, especially in ICOs, it's a really good thing to determine the validity of a project. Voting for third-party organizations that centralize a blockchain, well, that's coming back to the proof of stake and the delegated proof of stake. It is important that if a centralized, if partly centralized reputation system is realized and developed, the third party needs to be trustworthy and transparent. So this also means that if he has the data centralized, this data needs to be public to anyone else by means of a blockchain. So it needs to be open, and then if it's open, then they can still use some certain amount of data that they want, but then at least the user knows that the data is there. And maybe in the future it would be nice to show like a different use case for each data that is used. So for example, if you have a certain data collected in a blockchain of voting for an ICO project, and that data is valid, you can link a third party to it. So that means that the third party always has data that he can use, but the user knows which data is going to be used for what. So maybe that would be nice for in the future to also show the, like, with a smart contract within blockchain, what they use usually, and like with how do you call it, a process about like delivering a package, for example. You can trace the package from which step and where it is. The same with the data and the votings. You can see what kind of vote it is and what what it's used for, and that can be realized with a smart contract to see each step. This was my presentation about reputation systems and implementations of it.